what we're trying to do here, we'll go through, the what, why, and the who a little bit. And then we'll try to cover as much as we can. Since this is the first day of the course, I've been told by Sheikh that this is something that we would do as if we were doing a real course. So I'm going to assume that we are doing a real course and just go with how we are doing it as we have done in the past. All right, so the objectives, the what. We are going to do a preview of the entire detailed course. That means we are going to look at what are the technologies, what is the index, and so on and so forth. Give me 1 second. So we're going to do a preview of the entire detailed training course as much as we can. We're going to run at 10x speed. So think of Netflix adjusting the speed of run. If you use Netflix, you can adjust the speed of the play button. So that's how we're going to do it right now. We hope that you feel your time was well spent and insightful. We are going to take some breaks at strategic points and to address a Q&A and hopefully data analytics sparks. And then the skill level of this course is basic to intermediate. The bar that I would like to put around is basic, intermediate, professional, and expert. So we are at the level basic to intermediate for this course. All right, what this course is not. So this is not an exhaustive course for data analytics. The world of data analytics is extremely big. There is an ocean of things that you can do here. And so this is not an exhaustive course. We are not going to dwell on the boundary between analytics, engineering, and science. So in the industry, when you start searching on internet for anything related to data, you'll end up looking at what is data analytics, what is data engineering, what is data science. So while we touch upon our own definition of where the boundary is, we are not going to dwell too much on the boundary here. This is not a course that will guarantee a job. The job guarantee is a complex equation that requires collaboration, and we need to meet somewhere in between, wherein we do, as a course provider, we do whatever we can, but it also depends a lot on the student themselves in terms of their interest, their hard work, their discipline, attitude, and all of those come into picture. Okay. All right, why we are doing this. So once we have covered the what, why we are doing this. So hopefully we can narrow the gap between employer expectations and labor market skills. As you know, that is a constant battle and a struggle in the market. Employers always say they don't find the right skill set to hire more people, but at the same time, graduates coming out of the schools and who want to do lateral movement, working professionals, they always say, well, the employer expectations are a bit too high, and everyone needs a Superman or a Superwoman. So we are trying to help narrow the gap between the employer expectations and labor market skills. We love doing training courses. We have been doing this from a long time. Our faculty is lifetime dedicated to digital domain. So we are very passionate about learning and knowledge sharing. The evidence for all of that you would see in a moment, wherein we do contribute quite a bit to open source, we blog, and so on and so forth. We right now focus on quality and niche skills, which is quality over quantity, because you can do thousands of courses, but then there would be dilution in the quality. At this point, we are focusing on quality. So for this data analytics course, it's going to be of very high quality, and we're going to focus on the fundamentals and very niche skills that are in shortage in the labor industry. Now, there are some of the links there. Why data analytics is the career of the future, data literacy and analysis, a must for every job, and data analytics literacy. Those are hyperlinks. Later, when Sheikh will share the presentation, you can go ahead and click the links and read about it. Those are good reads on why data analytics plays a crucial role. So as far as I know, the who piece, this is Transfotech Academy and Queen's College Tech Incubator. Those are the entities that are collaborating for this course. So I'm going to skip through and go through the next slide. So why am I qualified, or why should I be doing this course? So that's my brief profile. From a work experience, I have about 20+ years of software engineering. I've had great experience both in corporate, enterprise, and startups. Worked across a range of industry domains as well. I worked in about 4 countries, lived, worked, and participated in communities. I'm also a book author of one of the popular Android continuous integration. That's not necessarily related to data engineering, data analysis, but it has a huge value in the mobile application development space. I do contribute quite a bit to open source. My education wise, I am a bachelor's of engineering, computer science, and have an MBA from Duke University. My contact info is there. You can look me up online. You can read about what all I have contributed so far out there. Skills wise, I still code to this day. I love coding, and I'm a polyglot developer. I do speak multiple languages, and in my full-time job, I'm a technical leader, and I like to call myself operating with empathy. Extracurriculars, I do teaching, training, and mentoring. I do pro bono consulting, quite a bit of things that I'm very passionate about, and I do play table tennis, ping pong, which is my stress reliever. All right, so these are some of the websites and blogs that I maintain. So you're welcome to go ahead and read anytime if you have any questions. And again, this will be passed on to you. The first one is where we do multiple training courses. The second one is all my source code. And the third one is related to automation testing, which is what Sheikh and I did for quite some time. All right, that said, let's move on to the first poll. As I said, I'd like to keep this interactive. Let's do a quick poll. I'm going to paste this link in the chat window. You can go ahead and answer that. And then I'll bring up the result screen. So the question is, which job might be automated away first? I'll give another 10 seconds and then we'll stop the poll, okay? All right, let's stop and then take a look at the results. So let's read. So about 42% said it's an actuarian, 21% said school teacher, 21 doctor, and 16 engineer. Yeah, the correct answer is actuarian. Actuarian is the job related to accounting, wherein you can define the rules of the job. So anything wherein we can define the rules in a software manner, those have higher probability of getting automated away first. Because essentially what is software? You're modeling the real world business rules into an automated system. That essentially is. But it's interesting to note that folks think it is school teacher. School teacher is a very tough job, as many people might not appreciate. Dealing with a bunch of kids is very human and very different from what a machine. You can't define the rules of working with the kids necessarily. It's probably a little bit not appreciated as much as in the industry, but personally, I think school teacher is a very tough job. But anyways, let's move on and then we can. All right, so with that said, let's talk a little bit about the terms that you might hear online. So as soon as you start looking up data domain, you would hear terms like data analysis, data science, data engineering, right? So I'd like to put that in a Venn diagram, and from a 20,000 foot level, if you zoom out and look at, okay, how can I define and put some boundaries around this? So the way I'd like to define is, all of these have intersection points, and of course they have disjoint areas that are purely related to them. So for a data engineer, I do consider that a data engineer should have some experience and knowledge about software engineering, which would be version control, 12-factor principles, being able to write software code, build, develop, debug, deploy, scale it, and so on and so forth. but also should have some fundamental rooting in the math, stats, and algorithms. A data analyst is similarly should have some amount of stats background and a very good data communication piece of it. And then a data scientist, as you can see, my definition is someone who knows all three areas really, really well. In the industry, I work for very large enterprises, and I deal with a lot of big clients, which operate in millions of dollars. And I can tell you that in majority of these companies, the word data scientist is not taken easily. It is not just learning a bit of statistical algorithms and applying a library of Python or Java or Scala and then calling yourself a data scientist. That's not how it works. You should really have had a PhD in statistics. You should have had published a lot of papers, and you should have implemented some of your recommended algorithms in a library or something like that. And then only someone is called a data scientist and rises up to that level. So there is a path in which I generally recommend if someone wants to get into the data world. We'll see that in a moment, what I believe the path is, and which have very high probability of converting and working with exciting companies in the high-tech world. So industry, word clouds. So word clouds is a popular way of representing the frequency of a word that can be trending across internet. So for example, when we did a word cloud trying to find out what's the relative frequency of the words on the Wikipedia, we found that analytics has the highest frequency. So the size of the word here represents the number of times, which is the frequency that occurs on a particular. Now, where was this extracted from? We'll come to that in a moment. And so that's the poll 2. Where did we get the word clouds from? So let's do poll 2. Give me a minute. All right, let's do poll 2. Let's give another 10 seconds, then we can go through here. All right, let's stop the poll, then take a look at the results. Okay, so 62% of them said that it's a code-generated image, though 15% and 50% think that some of them are created using Adobe, which is you can create in an Adobe or some kind of design editors like GIMP. There are many tools out there that you can use. Free stock images website, yeah, that's an easy one. You could always go to Google Images and pull off images, and yeah, of course, Google Images. So yeah, the correct answer is we use code-generated images. You can generate all of this with code, which we'll see in a moment, how the code looks like, and what if you want to derive your own custom images and use it in your own communication or any content that you want to publish on internet. How would you go about using that? So we'll see that in a moment. But before that, let's get through some slide decks, because I do want to get to the coding piece, wherein which I believe would be valuable for majority of the audience here. All right, so industry-wise, now there are lots and lots of indexes and measuring and numbers, statistics that you can get from various places. Now I pulled this off from Simplilearn. You can go and look it up. Data engineer salary across the globe, various numbers. Now in the United States, it says about $116,591. But understand that all of these should be taken with a pinch of salt. It depends on the candidate skills. It depends on which state you're working in. It depends on various other factors. But the point is to say that a data domain related, data analytics domain related job is pretty high in demand if you have the right skill sets. That's the message to take away from here. Okay, we have already done this poll, so I'm going to stop this. Okay, so moving on. Now, how do we put some structure around thinking about a course? So what happens generally is when you think about a course, the same course could be called with multiple names and abstractions. So if you might go to Udemy, you might call something as a data engineer course. If you go to, just making up now, if you go to some other X website, you might hear data analytics course, some data science course. And there might be a lot of content common across all of these courses. So how do you put a structure around thinking what is the value I get from a course? So the way I like to put, and I've been doing courses for almost 10 years now, is I like to put some meta, which is key and values. The top row where you see meta is I like to combine a course into tools, platforms, libraries, frameworks, domains, concepts, and programming languages. The values of each of those keys, you can see, start from row 2. Some of the tools that we might use is Python is an IDE, integrated development environment, VS Code, and so on and so forth. There are platforms, AWS, cloud. That's one of the massive platform there. You have Jenkins, Tableau, Cognition, and so on. Frameworks and libraries, and so on and so forth. So if you scroll your eyes all the way to the bottom, the way I'd like to call the data analytics course, what does it teach you? What is the value you get out of it? Is you will learn a Python programming language. You will use tools like Jupyter. You'll use frameworks like Pandas. We'll get introduced to a retail industry domain because we'll be using some of the data sets from retail. And then data analytics is the overall concepts that we are learning, and so on and so forth. So that's how I'd like to say what a course is comprised of. What did you learn from the course? You should be able to say that I learned Python programming language. I use some of these tools, some of these frameworks, and I can speak to some of the business domains, which is related to retail, banking, financial, and so on and so forth. Okay, so all of this will be shared with you. I just wanted to bring a frame of mindset when we think about what is a course. All right, so as I said, roadmap to data field. These are some of the hard and soft characteristics that we at Transfotech do consider, which is a roadmap. Some of these are subjective and some of them can be objective as well, depending on the scope and the context we're talking about. So having analytical skills and a persistent hunger for details is something which tells that you might be more interested in a data domain. Now, we are putting a perspective around, is data domain something that you want to do? Or do you want to do application engineering? Do you want to go develop mobile apps? Or do you want to just go and probably write backend APIs? So there's lots of things that happen in the tech world. So these are some of the things we think, if some of these characteristics match with what you have, then there is a higher probability that you might fit in a data domain. Now, the extinction by instinct and versus analysis paralysis is a spectrum which everyone falls into in decision making. So you don't want to be making too fast decisions and become extinct, which is, you make decisions with instinct. And neither you want to be on the other end of the spectrum, which is you keep on analyzing and then you essentially paralyze. You don't get anything out of it. So the sweet spot is always between these two extremes, right? You don't want to be on extinction by instinct, or neither do you want to be on analysis paralysis. So we help you get there, identifying your sweet spot as we go through the full-time course. Client side versus server side, this is one of the most fundamental things whenever we get into the software engineering field. Open source tools, probably a decade or 2 decades before, there were a lot of proprietary tools wherein even if you wanted to experiment and wanted to understand the latest and the greatest buzzwords and apply something and get that light bulb moment or an epiphany, you would not have probably gotten. But now, I mean, there's just no excuse. A number of open source tools out there. Those are free. Most of them you can download it, install on your own box, or you can just go online and just work through it. So we believe that all of it is already out there. Programming and scripting fundamentals definitely required because we are teaching you the fundamental blocks here. Think of Lego blocks. That's what we're teaching you here. Industry in general, where it has been converging is industry prefers specialists to generalists, generally in the data space as well. I'm an MBA graduate from Duke University, but still I would say that I'm less preferred if I sell myself as an MBA from Duke University in the data domain versus selling myself as a computer science engineer. And so industry does prefer specialists from a job perspective, from the team in which you operate, from what you do specifically, and so on and so forth. Not knowing software engineering concepts is generally a sin for a computer science graduate. I've worked with many students, I've hired many students, working professionals in my 20 years of experience. And I did come across folks who probably did not have basic understandings of data structures, algorithms, operating system, platform, databases, and networks. These are fundamentals that are taught in your course. And I do believe that for a computer science graduate, not knowing this is a sin. Now, there are folks who come from other fields. They do have some time to get onto some of these fundamentals. But everyone has to catch up with software engineering concepts at a minimum level. And then from a version control, should know at least Git. There are many out there. There is Subversion, there is Perforce, there's so many out there, but then Git is the most popular one. And anyone could just go sign up your account on a GitLab or a GitHub, and then you can start understanding the fundamentals of version control, and then contributing code. So these are some of the things that I believe are definitely guidance towards entering the data field and progressing your career path towards that. All right, we already did this poll. I'm going to skip this. All right, so the environment-wise, what do we give? Is we'll be using majoritarily Jupyter, a notebook interface for all of our classes. And the way it would look like would be, so you would have all your classes organized on the left. You could turn this off. And then you would have all your classes, and then we would be teaching all of this. So in terms of your environment would be looking something like this. So each one of you will be having your own server that we will launch, and we maintain the environment centrally in a cloud. Each one of you would be getting your own server. So you can launch the server at any point in time. And session timed out, so let me log in back. So each one of you will be getting all your classes. And so what this means is that you would have a centralized, all you have to get is a browser with a good internet connection, and you will be executing everything in the cloud. Now, if you are more intrigued and you want to experiment on your own laptop, we help you with that also. But this is the default environment in which you would be operating. So at any point in time, you can go to control panel and stop your server. This helps with saving some dollars because you can always stop your server there. So, and of course, there are other things, which is you can disable your token. Let's say if you believe that your machine was for some reason hacked and so on. So we have a very robust and a standardized environment, a lab, if I might say, that you can work with fully. Okay, moving on. From a overall, buzzwords or technologies, tech that we'll be using in the data analytics course, we will be covering Python as a programming language. From a frameworks perspective, we'll be touching upon Pandas, Apache Spark, Koalas. Pandas, Spark, and Koalas are massive computing / data munging technologies, frameworks, if I might say. Tableau visualization tool. Metabase is a dynamic visualization tool where you can publish your work on the internet. Databases will be touching upon PostgreSQL and MySQL. NoSQL, you'll be touching upon Elasticsearch, MongoDB, and Couchbase. Search-wise, Elasticsearch. Operating system, it's your choice. You can either have Windows or Linux. Both of them work. We teach on both of those. Data formats will be mostly touching upon structured formats, wherein you are able to define a schema, something like a spreadsheet or a JSON structure, or something wherein you're able to define a schema around it. Platforms wise, now you might not necessarily be learning AWS or Docker, but you'll be using some of these things. At least you will have some kind of understanding how these platforms might work. From a version control, we'll be using Git client, and all your code during the class and everything goes into GitHub. Now, though it is possible that there are flexibilities around it. Let's say if you would like to check in your code to your own personal GitHub server, all of that is possible. These are the default ones that we share. All right, so let's do a quick poll, and hopefully after this we'll get into code and start executing some of these things. Who trademarked pivot table? So I'm going to paste this here. And by the way, please don't look up internet. Answer it honestly, I'm not cheating.
Pradeep, this is not the right poll.
Oh, I'm sorry. Okay. Sorry about that. Let's get you the right one here. Thank you.
Mm-hmm.
All right, let's give another 10 or 15 seconds and get moving. Oh, I see a question from someone. Will we have an opportunity to get the slides? Yeah, absolutely. I mean, you can always reach out to Sheikh. Sure, you can get the slide deck. All of the code and everything what we're going to show is also available online for free. We are very big fan of open source. So you have all of that available. Okay, so let's start the poll here, and then let's take a look at. All right, so let's see. 65% Microsoft, 29 Pivot Labs, and Amazon. Yeah, the correct answer is Microsoft. But let's be specific of what is actually trademarked here, right? The word pivot table with camel casing, right? The P uppercase and the T uppercase. That's what is trademarked by Microsoft. You can use variants of if you change the case sensitivity. Let's say you make P lowercase, put a space after pivot, then that's not trademarked. Okay, so that's an interesting thing, which unless you are dealing with a lot of pivot tables, which majority of the business folks who work with a lot of large clients do all the time, wouldn't probably know. But all right, so that said, let's get into some coding. Since it's been about 37 or 40 minutes, let's take a quick 5-minute break. What do you think, Ying or Sheikh, or should we just continue?
We can maybe do some stretch. Have people.
Okay, perfect. Yeah, no issues. All right, so let's continue. And so what we're going to look at is we're going to look at some use cases here, because use cases are the ways in which we are going to teach how you can apply some of the concepts we are learning. We'll look at which data set buying a home, but let me just go in and start projecting. So the class 1 that we are going to teach is going to be class 1 exploration, which is how are we going to use something called pandas. So we start with basic exploration. Each of you would be able to do this in your own environment. All of the code blocks are documented wherever necessary, so so that you don't have to necessarily cross-reference everything online unless you have specific doubts. So here what we are doing is, we teach you how to read some structured files. For example, we are reading a file called height and weight.csv. We teach you how to print the values once you load it into something called a data frame, which is a fundamental data structure that Pandas starts with. Shape is something, which will tell you the structure of your data frame, how many rows and how many columns. If you do an info, for example, a command called info, you would see each column, whether it is null or not null. What is this data type? D type stands for data type. Now there are certain data types that are by default defined by Pandas, and all of those structure has been defined. Now you can, if you have numerical data, you can go ahead and do some statistics around it, right? So you can do mean. Head is something which is, if you want to get the top 10 rows in your data, you can do something like head of 10. Tail is the inverse of that. You can get a sample of 100 records of just sampling out of your entire data. And then if you describe, what describe does is it applies a bunch of operations on each of your columns, and you would get count, mean, standard deviation, minimum, 25th percentile, and so on and so forth. These are some of the statistical measures that you would get. Now these are all obviously applied to numerical data. So you can apply either on the entire data frame with across all of the columns, or you can apply individual columns, and so on and so forth. So you can plot these. Why you generally do all of these things is because whenever you're given a data set, you just want to know what are its boundaries, right? Like how dispersed it is, how distributed it is. And these are some of the fundamental things that when you learn 101 statistics, you're going to do all of these things. Now, if you want to know how two variables move, then you find the correlation coefficient, and you can plot a histogram. You can when you plot a histogram, depending on the number of data points and depending on how it shows up on your screen, you can increase the the bins, the buckets in which it can show. So this is a little bit too clobbered together, so we can increase the bins to make it more granular. We can plot, when you do a default plot, it just does a scatter diagram and so on and so forth. You can control a lot of these other things, like instead of a dot, you might want to put an O, you want to control the color, you can do all of those things. So this is essentially, once you get a basic data set, you're going to work through all of these things to get a mental understanding of how your data set looks like. Now it depends on the use case, which ones you want to use, which functions and operations you want to use, and so on and so forth. Let's skip this, and let's talk about what all Pandas can do overall in terms of the various formats. Because data comes in various formats. Data comes based on if you're dealing with transactional systems, large enterprise companies, you might be working with relational databases, or sometimes you might be getting the data that has been transformed in many more steps even before it reaches you. So sometimes you might get a CSV, sometimes you might get an Excel, sometimes you might get a database connection, and so on and so forth. So there are many data formats in which. Now Pandas is very versatile in terms of handling any kind of structured data set. These are some of the examples that are provided. And so, you can read an Excel, you can read a tab separated file, CSV. Parquet is a very efficient and optimized columnar data set, wherein if you're dealing with hundreds of gigabytes to terabytes, typically your machines don't have enough storage to be able to put that. So what you can do is, if you convert the data to Parquet, typically you get a savings of 10x. So let's say if you had a 500 GB data, then if you convert it to a Parquet, then it's going to come down to about 50 GB. Now those are just rough numbers. There are exceptions though. In the industry, Amazon Web Services, Microsoft Azure, Google, all of them do recommend converting, especially when you're doing data warehouse analytics, by default, whenever you store it in a storage system, it goes into a Parquet or something called ORC format. ORC format is whenever you're dealing with Hadoop. Hadoop comes with default ORC format, but Parquet format has been more popular in the industry, and it's been gaining more popularity since 5 years or so. I use Parquet format heavily. I deal with terabytes of data, and I do use Parquet. So the point is to say that Pandas has the maturity and capabilities to handle almost all kinds of data formats that you can work. So once we get that, we also talk about relational databases. Depending on the database that you work with, Pandas does provide, Pandas has support with SQL Alchemy, which is essentially Python's library to deal with databases. So whatever Python supports, Pandas supports all of that. So we will be using a relational database. We have a sample mock database that we'll be using, and there is a structure. This is essentially a movie database wherein you have some customers, staff, store, filament, and some relationships between all of these things. And we'll be using that and then doing some analysis using Pandas to get that. So for example, this is, there will be a bit of time as we go through more and more to depending on the use case we need. So let's look at some of the examples, right? So let's say if I want to connect to a database. So the way you would do is, you'll first execute the constants, and then you can, oh, okay. So my database is probably not running at this point. So I'm not going to do this. I'm going to clear the output here. And so you can see I have my Postgres sample data. By the way, all of this code is online. You can go in here, and we use something called Docker to kick this off. So I'm going to launch a terminal from here. As you can see, all of this is within the code base itself. And I'd like to see what ports it gets exposed to, 5432. I'd like to change it because I already have a server. Let's just put this 54. And so I can quickly go ahead and do, what I'm doing here is I'm bringing up a database server with sample data in it. All of it would be done, pretty fast, and that's one of the technologies, as we said, we'll be using something called Docker. That way, you can have multiple servers on your own box, and focus on what the course content is without necessarily having to be bogged down by, oh, how do I set up this server? Is it a massive administration activity that I have to go through, and so on and so forth. Okay, so you can see it started, and the port on which that's listening to is 5434. So if I get in here, and let's do this. Okay, so you can see what happened now. The database server got in, I connected to it, and then I'm able to extract data from a table called film, right? So that's how easy it gets, with Pandas and Docker. You can start, this will be all your lab environments you will be doing entirely from the browser. So you can select specific columns, and these are all database fundamentals for learning relational databases. You can pretty much, as long as you know SQL, you can execute any SQL query through it. So that's about a little bit about relational databases. I'm going to discard this, and I'm going to stop that as well. Okay, so let's go back to class 1 Explore. Now let's get to, let me get back and see that I'm not missing anything here. All right, okay. Sounds good. Scrapers. So one of the things that you would be working on, especially to get varied data sets, is sometimes you might not get the right data set that you have. So how would you go about, on the internet, there's a lot of data out there. And frankly, Wiki is where I generally look up for any data if I need. So for example, let's take a look at COVID statistics. Now, this is one of the most popular thing. I just pulled this up just for this course. So since COVID is, hot topic out there for anything. So let's think about this, right? Let's say you wanted to do a random COVID analysis, meaning you wanted to find some answers. So first you need to get to the data, right? So if you go to Wikipedia, you always have this data constantly updated, right? If you go here, this data is constantly being updated almost every day. Let's say you want to do some analysis on this data, right? Maybe you want to find which country is better than US, which country is worse than US in its recovery rate, or some other, something that you want to do. So how do you go about first getting all of the data into memory and then start doing it? So it's as simple as this. First, we use some library called Beautiful Soup, and we go get all of the data. So see, as soon as I execute this, it actually has gone to that website. It pulled all of the data, pulled all of the table, and all of my data is in here with 230 rows and 6 columns, right? Now, obviously, this might need to be cleaned up a little bit more for you to be able to analyze, especially because, see, there is 2 levels of columns here, not just 1 level, right? So I can quickly save this data back because I don't want to be going to the internet every time I download, right? I just want to be optimizing that. I can do an information to see, how it looks. I can also see that it's multi-index, which means there are 2 levels of columns. So I'll drop level 1 because it's not giving me any additional information. And then I look at the table. I see I've dropped location 1, convert it to a list. All of these are cleaning operations, which we essentially do when we have data. Because we want to name our columns much better than what you generally see. So in my case, I have ultimately come to a point wherein, I was able to name all the columns as location, cases, deaths, recovery, and reference, anything else that is required. So let's say I have a question, which is identify countries that have less cases than that of India, for example. Okay, so how do I go about doing that? So I can quickly get information, and here is the query from Pandas, which will give me all of the countries that have cases less than India. So essentially what there is a syntax for it, which is what we are telling is from the data frame, we need the cases less than that of the cases for India. And then we retrieve the value out of it. So there are about 169 countries that have cases less than India, right? In this data, actually, there might be data quality issues. Sometimes you might not have numerics in places where you are supposed to have numerics. And this is the problem with majority of the data sets that you get out there. And even with enterprise databases, you will always tend to, you might think that a column has numeric data, but sometimes strings will come in and that disrupts the way you want to do analysis on. So cleaning is a very common operation that Pandas lets you do. And so for example, this is one of the ways wherein I expect all the cases to be numeric, the number of cases, but I'd like to check upfront. Is it numeric? Is all of the cases numeric? So I can do this and then I can quickly print this. And I can see that there are about 227 rows only out of the entire data. Like initially we had 230 rows, right? But 3 rows have cases which are not numeric. And in my case, what I've done is I have extracted rows only that are numeric. So this is more cleaner data to work with. So let's say you want to plot all of these cases, right? So you can quickly plot this. Oh, sorry. I need to execute this because I'm trying to get all of the data table cases that are less than India, right? We can execute this and you can see that we'll be able to plot. Now, this interface, see, so there are a lot of data points in this, right? All of these countries have cases less than India. Now, obviously, this is not readable. So what you would do is there are options wherein you'll make it a little bit more readable, right? You can stretch this. There are all sorts of things, like you can increase the size of it and so on and so forth. Let's say we are looking for countries that have more deaths than of India, right? So similar analogy, and then you'll end up, doing something like this. So what this gives you, essentially, what Pandas is giving you is a way to converse. In a large enterprise organization, you're having conversations with other teams or external teams or other clients that you're working with, and you're making decisions based on what you see. And if there is big data that you are working with, then sometimes you can't load a big data into an Excel file, or you can't open it even in a text file. So you would have to work with systems that can handle big data. So Pandas is something that you would initially start off when your data size starts getting in the order of GBs. Anything greater than, again, it depends on the number of columns you have, but essentially if it is something that you can't open it on your own machine, laptop, then it is a problem of the big data that big data systems only can handle. So on and so forth. So we kind of see how easy it gets from scraping the data online to being able to publish and visualize anything. Now, the next step would be, obviously, let's say you want to go and publish this data, your analysis, you want to publish this out there, share it with the world, and then invite comments. And we'll be taking a look in a moment how we get to dynamic visualization. So this is all static visualization, right? So you would have to explicitly come and execute it. With that, let's get into word clouds. So in the previous poll, we talked about how do we generate word clouds. So again, we import Wikipedia, which is a library that is available in Python, and then we search for this data, right? So this code essentially calculates all the frequency of the word data analytics by retrieving all of the data from Wikipedia, and then it applies a visualization which is used from word cloud, and then it displays the whole thing. So it takes a bit of time, but then it does show. So see how it shows here. Of course, you can change the colors and so on and so forth. So folks who answered before, yeah, you can generate majority of these visualizations from the code itself. Okay. You can apply other customizations, which we'll skip for this in a moment. Like, for example, you have a rectangle here. Let's say you want to apply a cloud frame, right? Instead of a, so let me execute this. Okay, see how you can apply a cloud frame around your word cloud. So you can do lots of other things around this. And the point being, the takeaway from this is that a lot of the infographics that you find online, sometimes when you want to use in your content, wherever you're using, you can generate all of it with code. And that gives you a lot of control and customization capabilities. Also, obviously, copyrights issues and other things, right? You would have to deal with if you just copy it over the internet. So you could use code to generate all of these things. And so there are other ways and other things which we will point you to how can you generate various other infographics. But this was a simple example of what we can do with word clouds. So we are about 60 minutes into the conversation, or maybe 57 minutes into the conversation. Should we take a break?
Yeah, it may be a good idea to take 5 minutes, and maybe you can also ask them have any questions.
Perfect.
And,
yeah.
And everybody maybe just stand up and do some stretch or walk around.
Yeah, sounds great. I'm available. I'm not going on a break. So if folks have any questions, please.
So you can take a break too.
I'm good.
Okay. Maybe 3 minutes.
There's a question, Pradeep. Someone's asking, how can I access the code?
Yeah, so the code is all accessible. Like, if you go to github.com and then go to TechSparks Guru, all of the code is available here, data analytics Sparks. So it's open source. You can just pick up the entire code. And, Sheikh will obviously pass it later to you as a follow-up. Hope that answers the question.
There's another question. Someone who has an engineering degree from Pakistan, he's asking, do company hire candidates from the data analytics bootcamp?
So the answer to that is not a yes or a no, but let me qualify it, putting some scope and context around it. In my experience, I've worked with folks from non-computer science engineering, tons and tons of them, from mechanical, from electrical, from medical fields, who passionately learn software coding, get into the data field, and in some cases, they do better than some of the computer engineers I've worked with. So the real question I would say is, companies accept people as long as they find valuable skills that you learn. And the way to learn skills, it's everything online these days. You have access to information. There is nothing stopping you. It is having some focus and going through the structured learning and really believing in and passionate about things. And I have found folks who came from non-engineering backgrounds and do really well on the computer science jobs or engineering jobs, if I might say, software engineering jobs. So there are still, there is a good chunk of employers, like when you apply, they still would have a question on the form which says, well, do you have a computer science degree? Now, some employers do use that as a filtering criteria to not even interview, but I can tell you that that trend has changed a lot. Google has removed the need. What's we call it? GE has removed. GE is one of the most standard companies in terms of processes and other things. GE has removed the need for it. So they look for skills. They essentially look for skills. And as long as you have skills that you can prove during the talk and during the coding test that majority of the employer gives, I think the world is open out there to get in and get this kind of jobs.
Thank you, Pradeep. I think the extension of the question was that if someone has a foreign degree, then what's the case? I think that question already got answered.
Oh yeah, there is always an equivalent of a foreign degree in the US. Employers don't necessarily disqualify you based on the degree. They look at the degree. The degree becomes a question only when we are not able to perform well during the interview process, right? If you're able to perform well, get the skills and display your skills, I think everything pretty much goes well. And especially the market these days, past 2-3 years, has really opened up. Employers want more and more skilled people, and the labor market does not have enough labor to be able to supply to meet the needs.
I have a question for everybody. How did you find this class level of difficulty? Do you find it very easy or very hard or somewhere in the middle? Just type in a number. I'm just curious.
Yeah, so what's the scaling? Because
1 to 5.
1 to 5, there you go. 1 to 5, please go ahead and type your number.
Yeah.
And 1 is easy and 5 is hardest.
Right. I think some of them did have an intro Python class, like a 3-day class. Okay, so it's a bit on the harder side. Yeah, okay, which is good, which make it challenging.
That's a good one. All right, it is hard. You got to do more of this.
Right. So you have a higher goal to reach, right?
Right.
If you know everything, there's no incentive to learn.
Right. And frankly, anything that you do not know seems hard at the beginning.
True.
As you cross some of these chasms, you'll be like looking back and like, what did I really think about? It was so hard. And frankly, I have barred this course or, measured this course as basic to intermediate. I didn't even get to the intermediate to professional or professional to expert, which I do teach for many of the working professionals.
I have another question, Pradeep. It's someone asking, have you ever worked with the data analytics intern at your company? So I think you'd love to answer that question.
I did. I do hire a lot of interns, actually. In fact, I do teach courses where I work full-time as well within the company. I do conduct courses, and I do hire data analytics interns quite a bit.
Hmm. So here, I have a question, actually. I think maybe 2 or 3 years ago, a lot of companies only hire like PhDs working on data-related work. Now it looks like they're going down to masters and to undergraduate, and to your earlier point, maybe even to someone who acquired knowledge without a degree. Is that what you see, or?
Yeah, so I think depending on the segment of the industry. Now, for the senior roles, it is still true that they would look for PhDs. I don't think they're looking at someone with just skills and then lesser years of experience. And they do look for PhDs and some amount of software engineering experience. That said, the amount of opportunities for newcomers having, skills learned, which, that's what I mentioned previously, specialists over generalists. You can learn courses and as long as you qualify the coding test that the company gives, and you have a profile online, like if you constantly do HackerRank coding exercises, or you have a blog, or you contribute to open source, hiring managers, I know many of my colleagues and including myself, we look for what have you contributed out there that already speaks to your skill level, because that means I don't have to teach you when you come into the environment and you get running with what the clients need.
Right. I have 2 other questions. One is regarding the industry knowledge, how important it is for entry-level job applicants.
I think that's a tough question, Ying, because industry knowledge and maturity is something that can ripe only over years of working with domain. That is hands-on. One cannot just read it, right, and then learn it. You would have to go through teamwork, collaboration, work with various domain experts, and there is no yardstick specifically for the industry knowledge. You have to work in the industry for years to be able to get that. So at least me, when I look for folks out there, what I look for is not depth of industry experience for freshers and interns. What I really look for is, did you have enough, are you spending enough time learning at least the technology that is in your control? You anyways can't control what happens in the industry until you actually work in the industry. I think it would be unfair to expect industry knowledge from freshers. But once someone crosses 3-4 years of experience, definitely industry matters.
What about open source projects? Is it easy for students to find those projects to participate in or get some experience that way?
Yeah. So if someone spends a good amount of time on GitHub, and I'm just talking about one platform, GitHub. There is gitlab.com, and then Facebook has its own, Google has its own projects. Just on GitHub, if someone looks for searches for keywords like data analytics, there'll be a bunch of projects or repos that come up. And the way majority of the developers work is, if you are able to check out the code, if you're able to set up your development environment and you find an improvement in it, then you submit an improvement. It's called a pull request, which is you're submitting code back to correcting some of it. And that's a very good indicator for the developers of the project to reach out back to you and say, hey, do you want to work on this module for the project? You can either get experience, or if it is worthy enough, they might even pay you. So that's how I have seen typically how people get hired for open source projects. It is not a traditional way of hiring.
Thank you.
Sure. What is a good entry-level coding language to learn? Okay, good question. So I'd like to do a poll here asking how many programming languages do you think there are right there? I'll give away the answer anyways, because I can't, we don't have enough time to do
40.
Okay, let's tens, hundreds, thousands. Let's go with that.
Mm.
So yeah, to save time, I'll be efficient. There are about 700 to 800 programming languages as of today. And that is leaving the scripting languages. Now, there is a difference between programming and scripting languages. Bash, Unix shell scripting, those are scripting languages. Perl is a scripting language. Leaving those, there are about 700, 800. So what is an entry-level programming language is depends on what industry you're working with, what are you trying to do, and so on. Now that said, in the data space, Python is the de facto language at this point in time. That is the most popular one, that has the most community support, that has the most libraries that you can work with, and so on and so forth. Now, but that said, if you're working for, it depends on the project you're working for the company. For example, on the server side, Java still rules, Java and Microsoft .NET framework. So people do expect that also, but that is more on the application engineering side. For the data side, Python rules. Scala is also another language that rules. But if you're an entrant into this and you want to learn something, I would highly recommend Python because it's relatively easier to catch up with, but has very high power and potential for you to scale across multiple domains and multiple concepts. So let's see, you're also an MBA graduate. What do you suggest that doing master in business analytics is better, or MBA, which degree has more scope? So it's not an or. For me, the answer is always do all, learn a bit of all, but also be an expert in one of the things. So think of, a step graph. You have x-axis as the breadth and y-axis as the depth. It's not okay in this current industry, especially in the tech side, just being a jack of all trades. It's not appreciated much. You can be jack of trades if you are a master in one. That is acceptable. So it is both. So the question to master in business analytics is better or MBA? It depends on which school you're working with. It depends on what is the course content and so on and so forth. It depends on your capacity to digest information. It depends on so many other factors. But if it has to be a binary decision and you want to get into the tech field, I would recommend business analytics is what might give you higher chances. But don't quote me, but that's what I would say. As I said, going back to my point, industry requires specialists more than generalists.
So here's another one, I think, in same nature. SAP, AWS, and data analytics. Which one is the best line for career in the future, especially for the people who are coming from non-software engineering background?
So let's see. SAP. Okay, SAP is a very, very massive enterprise resource planning software that's been there for a long, long time. AWS is a software as a service, platform as a service, and infrastructure as a service platform. These are not mutually exclusive. For example, you can run SAP on AWS platform and you can still do it. So these are all the terms that we are seeing here, data analyst, AWS app. These are not apples to apples comparison to be able to say which one is better. These are all massive different things. From a non-software engineering background, I think I would say the easiest would be to learn the data analyst among these three. But again, as I said, these are not apples to apples comparison. These are totally different things. So the question itself is, I think.
So here's my question. If somebody starts a career with learning data analytics here, can they improve their career by learning AWS and SAP to apply those knowledges into their data career, data analytics career, wherever they're working?
Right, so we don't teach SAP in this course at all. And neither do we teach AWS fully. That is a separate course. Doing AWS certification is all. what we will teach is a module in AWS, which also depends on how fast a student learns the data analyst concepts, and we can let them learn something called EC2, which is spinning up your own servers and being able to work with that. Okay, all right. So I guess there are no more questions. We can move back to the presentation. Someone had a question?
No, you can continue.
Oh, okay. Someone was saying Queen's College Incubator has a course with it. Oh, wonderful. Yeah, AWS is one of the most sought out, cloud platform out there, apart from Azure and Google Cloud Provider.
Yeah. And they have a data analytics certification also, but in order to do that, you really need to learn the basics first. And all the
Right. Yeah. AWS has a very solid course as well, but understand that AWS recommends all the tools that are hosted only on their platform.
Yeah, so that was part of my question, Pradeep. I just wanted to point it out to the folks that if you're learning, data analytics, you're becoming a data analyst, then, if you want to enhance your career later, you can choose AWS. So these are, like Pradeep said, these are not apple to apple, but you can get all of these fruits in your bucket. So once at a time, I think so data analytics is the basic, and then you can learn AWS in their data analytics certification. You can just bucket it, and then you can learn SAP and play into that domain as a data analytics.
Yeah, SAP is, I would recommend not to learn it as an entry-level job application. There are colleges that has specialized majors in SAP that doing SAP, and SAP usually will hire those into companies that uses SAP. Just randomly learning it is very hard to, I think it will be hard to get jobs. And SAP is so complicated, so big.
Yeah. It's just not just one thing though, right? It's like you have to identify first where in SAP you want to learn. There are 7, 8 modules.
Right. Oh, there was more than that. It's very complicated. No one knows everything.
True. There's business domain specific modules in SAP, and
yeah, even within the same module, you have people doing business analytics. You have people doing IT side. You have different people. Some doing configuration, some doing programming. It's and some that does security.
Right. Absolutely.
It's very. It's hard to say what you want to do. It's better you get into a company, maybe get a SAP related job as a user, maybe from there decide on maybe to do more, or pursue a degree in a college that offers that.
Right.
Salesforce also has a whole bunch of that sort of classes.
True. Salesforce has got a bunch of platforms. Tableau is now acquired by Salesforce.
Yeah.
Salesforce Marketing Cloud has its own roles, and each role maps to a different job. There's so much granularity there.
Yeah, but you got to understand data and how to collect it, how it's stored, what's the relationship, all of that would be handled here, right?
Right. These are the fundamental blocks, like the Lego blocks. These will apply whichever tool we use in the data space.
Yeah, doesn't matter. Yeah.
Okay, so let's get back to a use case. Real estate sales. The use case is essentially, when you're going to buy a home. This is probably a very dear thing, probably for everyone in their life when they want to buy a home, unless you're born with a golden spoon, which is another discussion. But for majority of the people, they end up wanting to buy a home, and it's like comparable to buying a car, but a little bit more complex. So how do you go about, before you go and talk to a real estate agent, wherein you're on the negotiating table, and you want to be equipped with the right data, because there will be circular questions all the time when you're talking to an agent or representative asking about, well, what's your budget? But then if you give up your budget, obviously the representative or the agent is going to give you houses that can eat up all your budget. But then if you don't give it the budget, how will someone identify what are the options to tell you which? So that's a circular loopy question that is always there in a negotiation. Who gives the information first? So how do you kind of break some of these loops and have more information so that you ask pinpointed questions and you don't feel cheated at the end of the day? So typically, majority of the states in the US publish data of the real estate sales of all the properties sold by state and by year and so on. This example, what we are going to show you is real estate sales from 2001 to 2017 for Connecticut state. This is freely available online if you just go and search. The US government publishes. For Connecticut state, they publish it. And many states in the US publish this kind of data. And this is published generally in a structured format, either in Excel or CSV and so on. So let's say, how do we analyze this? This is generally a big data set, and it runs into MBs. And so let's take a look at this data. So it has about 861,000 rows, right? It has various columns here. The ID, serial number, which year it was listed in, the date recorded of this transaction, whether it was bought, sold, and so on, the town in which it was done, the address, what was the assessed value for it, and what was the actual sale amount. And then, there's a ratio, and then what type of property is it? Is it a vacant land, residential, commercial, and so on, and so forth. So what can you do with this kind of data that is publicly available, and how can you be a little bit more confident before you get to a negotiating table? So let's say, you want to find out who all bought their homes greater than the average home price in a town called Andover. So it's as simple as it gets with pandas. You would find the sale amount, which is greater than the mean, and the town being Andover. So if you run this, you will see that there are 82 rows. So 82 folks transacted buying the home greater than the average price in Andover. So let's say, you already are narrowed down to buy a home in Andover County. Then you would want to know all of these numbers. If nobody bought it above the mean, then when you're talking to an agent, he or she says, well, 100 people bought it, so it will be okay for you also to buy it. You can instantly say, no, they did not. I have the data that proves that, right? So there itself, you're getting a negotiation advantage, a bargaining advantage when you do this kind of analysis. Let's say you're not decided on your property type. You have some budget that you want to just put in. So you can get the mean of all properties by property type. So apartments, condos, industrial land, public utilities, and so on and so forth. So you can do all these sorts of analysis just by looking at the historical data, right? Something like, is the assessed value correct? So for example, there is a sale amount and there is an assessed value, correct? You want to know how close are they, or is there a wide gap between those? So you generally look at correlation when you do that. Now correlation doesn't give you the full picture. There's lots of exceptions that can happen with correlation, but at least you get started with something. So if correlation is generally positive, that means both of them move together, meaning if assessed value increases, sale amount also increases. Correlation is negative, then they move in opposite directions. So you can do this kind of analysis. Now, let's say your budget is between certain range. Let's say your budget is 300,000 minimum, and then 350,000. You want to know how many people actually bought a home within that range. Why? Because again, you just want to know how many people. If no one bought it, then your budget is wrong. Or if too many people bought it, then you have more confidence that yes, my budget is correct, and I'm looking in the right town to buy a home that matches with my budget, right? So in this case, if you quickly run this analysis, you'll find that 58,000 of them bought in between 300,000 to 350,000. So it gives you more confidence before going to the negotiating table, and so on and so forth, right? So this real-time use case is something that you can apply in various other contexts, and it is required by US law to publish the data for the properties for various states, and you can pull this, and once you know how to use this kind of data with pandas, you're in a much better and a superior position at the negotiating table. So this is one use case. Now during exercises when we give in the classes, we have many more data sets that we'll be asking more questions, and then we'll be drawing some graphs and other things to be able to visually analyze all of these things. So that's about the real estate analysis. There's one more I wanted to show. So when we begin, generally you would need data sets. Like you want to have data sets. Where can I get data sets that I can experiment with? Typically you go to Google and say, hey, I need companies data set. I need universities data set. You might end up getting some data sets in platforms like Kaggle. Kaggle is the data science platform, cloud data science platform that Google maintains. And it's one of the most popular ones that started doing this. You might find some, but understand that you might not find majority of the data sets also there. And it might not be a big data set. It might just be 1,000 rows or 10,000 rows. What if you need more data sets? So there are, if you end up in Google, typically when you type for data sets, you'll end up with a lot of URLs wherein people do publish hyperlinks for data sets that you can use. But sometimes those hyperlinks itself are so complex that manually you cannot analyze. So let's take, for example, this website where the person maintaining this maintains a lot of data sets here. And these are publicly available data sets. Like you can have CSV, and then the doc gives you the schema. And it tells you how many rows are there, how many columns are there. But look at the number of data sets itself. Now, how are you going to analyze which data set that you want to use? Would you just go by number of rows? Would you look for certain keywords that you want to analyze with? How do you do that kind of analysis? So when I started writing this course about 2 years before, I thought this would be a good exercise for someone if they want to extract certain data sets. So let's say you want to work with product data set, right? So we could quickly run this. Now what this has essentially done is it has gotten to this URL and then it has saved the entire table with the hyperlinks in a data frame. And so once you have the data frame, you can quickly see what are the columns. And then you can find, let's say you're looking to analyze some products. So you can find that you want to find wherever the title, right? If the title contains products, then most likely it's a products data set that you want to analyze. So you can look for something like that. So there are about, okay, no, this is not giving the count, but you can always do the count. I would say make a guess about 20 of data sets that have product in its title. So maybe you want to work only with the products data. So you can do all of this analysis. Let's say you are looking for data sets with Australian and item gas. So you're working in a company or targeting to work in a company that deals with public utilities like gas, and maybe you're dealing with an Australian company. You can quickly look for something like this. So the point is to say that even for hunting for a data set that you're looking for, let's say you are looking for rows, at least 1,000 rows, you need the data set having at least 10 columns and the title contains product, right? You can do something like, so there is one row actually. So there's production of rice in Indonesia, which has more than 1,000 rows, has more than 10 columns, and its title contains product. So as soon as you have the URL, you can do all this kind of analysis. And this is a very useful way of identifying your data sets, like parsing your metadata of the data sets itself to know which data you want to use. Because you will end up most of the time after you have crossed the initial classes, right? After the initial classes, we provide you data sets. These are all the data sets that we give you: height, weight, we give you monthly data, real estate sales. These are all the things that we initially give you. But over a period of time, as you get more inquisitive about various other data sets, you can use this real estate, you can use this use case to identify which data set you want, and so on. So I'll stop there on the which data set. That's another use case I wanted to cover. And let's go back to our presentation. Okay. So symmetric labor metrics is another use case which I want to cover. What we have seen so far, drawing graphs or executing pandas in a notebook, all of those essentially are static graphs, meaning they're not dynamic, meaning as data changes, we are not getting the visualization changing accordingly. So typically, if you look at COVID statistics on Google or any other place, they're getting updated, by a certain frequency. It could be every hour, whatever they define, and so on and so on. So how do we get from static to dynamic visualization? What about concurrency? So let's say you have done some analysis, you have some visualization, and you have published it. How do you ensure that you're able to serve the information and data for all the users in the world, right? So how do you host it? What is the concurrency? Do 1,000 users connect to your server? Do 10,000? Because this is the real problem when you start publishing on the internet. What about scalability? How scalable is your website? Does it automatically scale if all of a sudden there are 100,000 users in addition to what you already have? How does that work? And real-time data. Does your website automatically serve real-time data, or there is a frequency? Maybe it serves data as of last 2 days, and it's always trails behind certain number of days or certain number of hours. How do you deal with all of these things? Now, this is what is real-time enterprise solutions that majority of the enterprises build software as a service addressing these concerns. So how do we go about this? So we are going to look at, I wanted to show you a case of, you must have probably read this. A 17-year-old built one of the most popular coronavirus tracking websites in the world. That has over 30 million visitors a day. And do you think it's rocket science to build something, a website like this, if you have done your own analysis and publishing it out there? No, definitely not. If a 17-year-old can do this, I think majority of us can do this. It's just, crossing that chasm for us and getting to the point wherein we have done our analysis and we just want to publish it out to the internet. I'm going to skip that poll for now and move on. So symmetric labor metrics. This is a very big and a massive project that we will teach you as we go through the course in various classes and touch upon it. What we're going to use is we're going to use some of the United States Immigration Services raw data that is available for public use. And we're going to look at the data from a perspective of an employer, the perspective of a candidate, what are some of the governance reports, what are some of the composition reports, and so on and so forth. So this is a massive project that I'm very passionate about, that I've spent almost 6 months to 1 year executing it myself, writing the code behind it, developing a data warehouse for it, and then making it an open source project. This project is also open source out there. Let's take a look at generally the process that happens is the data. I'll show you the data where it gets published. So typically when you go to the uscis.gov, data is published openly in the CSV format, or if you navigate to other places, you'll find some Excel formats and so on and so forth. This data is very small, but the data that we have collected over 1.5 years is very massive. It runs into at least 50 GB of data. So it's not just possible to send that data, it needs to be handled in a totally different way. During the class, when we get to this real-time project, we're going to teach you this process itself. This is the most common way with some differences in how data warehouses are built. And data warehouses are massive projects in many enterprise companies. They run into millions of dollars. You'll have lots and lots of people. What we are trying to demonstrate in this class is a simple model of how you would do this, because you would be able to talk about this, and then there is a good amount of shortage of people who can skillfully work on such projects. So what we do here is we download the source, we load it into pandas, and then we convert it into a format called Parquet. This is step 2 here. And then this cycle repeats for a while. The reason is there will be data quality issues when you try to convert it into a Parquet format. And so you would have to clean that up. So we'll teach you how cleaning strategies work. And this pattern applies in majority of the data warehouse projects that you work in. Then we do some exploratory analysis on the data, initial analysis, right? Because we are trying to get answers to some things. So we'll do some exploratory analysis. And if the exploratory analysis passes some tests and so on and so forth, we get into more cleaning, munging, we add new columns, we do some querying, additional querying on this. And then ultimately we make it ready for it to get loaded into a data warehouse. So what's a data warehouse? It's essentially a data source in which analytics data is queryable. It makes it, because typically you have transactional databases that are dealing with your transactional systems, and you don't want to be hitting your transactional database to do analytics queries. Let's say you want to do an aggregation operation, like sum of all transactions that occurred between the last 1-2 years. You don't want to be doing that on a running transactional database. That will bring down your bread and butter transactional system. So think of point of sale system. Let's say you're going to a retail store and then you're doing a transaction. Point of sale transaction typically is a transactional system. You don't want to be analyzing, oh, you know what, all the stores in North Carolina, I want to know what is the total sales amount. You don't want to be running that query on the database at that point in time. So what you typically do is you get all of the data from various transactional databases. Think of each transactional database being a different store. And then you figure out how to load all of them in a way wherein running aggregates on them becomes easier, which is essentially data warehouse. And then ultimately you get to the point wherein you do some static graphs, then you do visualization. You can also apply some dynamic interactive graphs, and then ultimately you publish to the web. So all of these are steps. This is the big real-time project that we'll be doing during the course. And I'm going to give you a preview of how it looks like. We are going to be using, so let me show you how it works. So initially, I'm going to skip the cleaning piece because it gets a bit dry, how to clean and all that. When we get to that class, we'll teach you that. But essentially, you will end up with a database something like this, which is a Parquet file. So once you come, you load it into your pandas data frame. This data set, we'll take a look at it, what it contains in a moment. You can see, how the amount of time it's taking to load itself it's a very big data set. So this is actually from 2001 to 2019. All of the visa records that have been applied to something called H-1B programs that have been applied. So let's do an info. And so you can see, these are all the columns. The year the case belongs to, what is the case number, submitted date, what's its decision date, what is its visa class, and so on and so forth. And then, where was the job located, worksite, city, state, postal code, and what is the normalized salary, and so on and so forth, right? So let's say I want to find out how many H-1B visas were sponsored from 2001 to 2019. So you can do something like this, and then you will end up looking year by year. Let me minimize this. Yeah. So this is about 60,000. You can see that on an average, the number of H-1B visas in the US have been steadily increasing, right? From 2001 all the way to 2019. Let's say, it's not just the visas. You want to find out how many were certified, meaning how many were approved. You can do that too. let's, this is all big data, guys. It runs into millions of rows, and so it takes a bit of time to execute all of these things. So you can see, on an average, the trend looks like the number of approvals are also going in the same trend as the number of applied, right? Let's say you want to find out the median salary of an H-1B software engineer, right? And you can do that. And as soon as you find that, you'll find that the median salaries are steadily increasing. In 2001, it was 52K. And then, in 2019, it was about 92K. Now, this is broad stroke of a software engineer in the entire industry. But understand that, even if you're looking at a data analyst engineer, it hovers around the same area. It's a proxy. It's a very good proxy of how you can estimate what the average salary is. Now, we have looked at the median salary. Of course, you can also look at the average salary. And the average is 96. The median is about 92. Yeah. The trend is overall the same, the average or the median, whatever you look at it, it's in the 90 case. This is across the entire country, right, in the US. Now, you can go down and get it by state, get it by city, and so on and so forth. All of the data is there in this big data. And so those will be all class exercises that we will be doing. Why this is helpful? This is a very helpful way, this is a very common problem, right? Let's say you're in the US and your goal number one is to make more money, and you want to identify which place or which city or which county or which state in the US pays more for a software engineer. Don't you want to know that? And maybe you are very dynamic, and you are not yet finalized the place where you want to live in. You are open to move anywhere in the US. You could do this kind of analysis, and this is all clean data that is published openly by the US government. So you can trust the numbers that come out of it. This is not some organization that has taken a sample set of data and then published their analysis on it. This is all available for publicly out there, right? So you can plot it on the map. For example, let's no, I'm going to skip that map because we need to load some mapping libraries in the backend. But essentially, you can even get to maps and so on. So all of that again is published in the Symmetric labor matrix is also, you can, all of this data is this is an open source repository as well. You're welcome to go ahead and see and do all of this. So for now, what I want to do is I want to show you how you can quickly visualize this, dynamically visualize this data. So what we have seen so far is all static visualization, right? You have to go and execute certain piece of code always to be able to do that. But what if you want to publish it onto web, you want to build a dynamic graph? So I'm going to use an open source platform called Metabase. So Metabase is a open source as of now. It has the capabilities of some of the proprietary tools like Tableau, Click. These are all the tools you would read online. Metabase will quickly let you connect to a database and then ask insightful questions to it, and also draw graphs, and then be able to publish it onto the internet. So in this case, what we have done essentially is we have already defined a database that is already published here. And then we have launched that database using Docker Compose. So all of the data is loaded with the seed data. And then now you want to focus on your analysis, like how do you want to analyze this? So let's get into Metabase. So let's say I'm already connected. The tables that I have are employer table, employment table, employment wage table, address table, SOC table. SOC is a standard taxonomy of how you would recognize every job. It's called Standard Occupation Code that is assigned by the United States Department of, I forget the name of the department though, but they have a standard taxonomy to assign a hierarchy to every job. And then NICE is the way you classify industries in the United States. So all of these, how you build, going back to this diagram that I've shown you, right? How do you do? So we are looking at all of these done, and we have already built a database, and we are at a point where we're looking at visualizing all of these graphs. So you can ask quickly questions like, I want to look at, I don't know, look at employment wage table. You can quickly get a quick summary like this. This many rows are there, the employment wage, how these are distributed, some basic statistics. You can see how many were certified relative to how many were certified, withdrawn, denied, and so on and so forth. Now, all I have done right now is just clicked one link and it gave me the entire analysis, right? So this is an open source tool called Metabase. I tend to use this mostly in my courses, though Tableau and other tools can also do all of these things, which we'll have a module where Tableau is much more UI aesthetic in terms of the options it gives you. But for an open source tool, this already does a very good job. So let's say I want to build a dashboard, something like this. The questions I'd like to ask is, I have some of these here. So I want to know by case and by status, right? In a pie chart. So I could do something like, okay, I'm going to skip this analysis, which I did not do. I'm going to ask a question, and instead of asking a simple or a custom question, I can do a native, and I can run it against this database and run it, right? So it has given me the count, the number of count who were certified, withdrawn, and so on. And I can quickly hit visualization. And in this case, what I want to do is I want to do a pie chart. And so it quickly gives me this pie chart. I can say done and then save this. I'd like to call it, case status pie. I can give other description and so on, but for now, I'll just save this. Add it to a dashboard. Not now. We'll add it in a bit. But then if we go back to home, we can do more of this. So let's do another one, which is essentially, I want to know by visa class. So I can ask a question. I can do a native SQL query, run against the LCA program. Okay, so you can see that by visa class, okay, let's get to the visualization. And we have all of these options enabled. You can pick pretty much. I'm going to select a horizontal bar chart. Okay, so essentially what it tells is among the visas, among the LCA program visas. So by the way, if you didn't know this, H-1B is one of the most popular visa program that is majority of the people come to the United States, but there is something called Australian. So US has a special agreement with Australia, wherein they come on an E3 visa type, which is equivalent to H-1B. With Chile, they have something called H-1B1. With Singapore, they have H-1B1 again. Okay, so all we are trying to do is, what's the number? So I can go ahead and save this, and I'll call it visa type, right? And save that. I'll not add it to dashboard. We will add it to a dashboard in a moment. And then, let's do another one and then build the dashboard. So you can do, let's say, let's plot it on a map. So I want to know by state how many visas were given. So I'm going to ask a question. Okay. And then I'm going to do a visualization. You can see, by state, it has been listed how many visas have been sponsored. I can do a map, right? And then I'm going to hit done. I'm going to hit save. Call it visa by state. Save this. Okay, we're not going to add it to a dashboard. We'll come back and add it. So we have added three questions we have asked, and we have built visualization. Now let's say I want to build a dashboard and publish it out, right? So I can go ahead and create a new dashboard, my dashboard, and it can go into a collection. You can define your own collections. Let's create that, and then you can add the questions, the three which we added, right? Let's add first one, case status bar. You can, adjust the layout, sizing. You can save it. You can add another one. Let's do visa by state. Okay, there seems to be a problem which we'll resolve it in a moment, but let's just put it here and then save it and add another one, visa type. Okay, and drag drop. So this is all, drag drop once you have built your data warehouse. Let's save this. And let's get back to visa by state, what's going on. Let's take a look at that. So visa by state. Okay, so let's go to settings. Okay, region map, we need to select United States, and then let's save it and save this. Okay, so let's go back to our dashboard now, and you can browse all your items and my dashboard. Now you can see, you're quickly building dashboards like this by introducing various insights and questions that you have out of your data. And this layout is pretty flexible. You can keep on, introducing as many insights and if I may call it visuals, infographics that you can put in. And these are interactive. For example, if you hover on California, obviously California would have the maximum number of H-1B software because tech pretty much in the US, if you have to order it, the top one, California is the one that majority of the tech happens. But interesting thing, if you notice, the next state that has the highest number of visas is Texas, which at least I wouldn't be able to guess outright. I would have thought New York, but New York comes third, right? And so on and so forth. So you can come. Now, let's say you want to publish this dashboard out for someone to be able to consume. So for that, again, Metabase gives you easy, you can publicly share this. You can share the dashboards and you can go back. And then here you would find sharing and embedding. So now obviously, it's published on localhost, which is mine, but then you can publish it on any domain that you want to publish it. And once you publish it, it will be accessible for anyone outside, right? So I can, right now I'll access it on a new window and see how it looks like, right? See, this is how it would look like. This is essentially what you're looking at, when you go to COVID statistics on Google and various other places for whatever analysis and data that you're looking for online. And all of this is done with open source software so far. None of it is proprietary. We have not paid any of it to anyone. Now, where you would start paying is because some of these differences, those little things which might consume more of your time, you want to make it a little bit easier, then you tend to go to tools like Tableau, you tend to go to tools like Click and other places. Obviously, you're trading off your time with paying a little bit license fee to these tools. But then with what we have out there in the data analyst space, there's pretty much a lot of it in the open source that we can do end-to-end data analytics. So, okay, I'd like to pause here. What we have done here is, gotten from data, scraping the data, being able to build a data warehouse, and being able to visualize it and publish it to the internet. All the 9-yard end-to-end, which is like the holy grail of what you would do in data analytics out there. Every company that wants to go public or wants to become a SaaS software company essentially does this. So anyways, let's get back and we are running out of time. We are about 8 minutes. Okay, homework, not yet. We'll have homework in every class. So the reason I post this infographic, this is the general trend in which majority of the technologies that come and go in the industry happen. There are innovators, and any software that gets too much hype on the media and the internet always has peak of inflated expectations. So there's too much hype given to initial software. And the point I'm trying to make here is that do your analysis, do your study on understanding the details of a software technology and not just be carried away by what you see necessarily in the most trending thing on the Twitter or the most trending thing on the Facebook. And the reason I'm telling this audience and not a general audience is because, we are engineers. We need to understand that we need to give enough credence and analysis and give some thought when we look at things and be able to separate wheat from the chaff. Look at, is it really the truth or is it just being hyped? So any technology goes through the same thing. So whenever you hear new jargons and terms, always keep this in mind, that it could be a peak of inflated expectations. There will always be early adopters of some technologies. And then there is this big chasm. It's called Trough of Disillusionment. Every company, every technology, every product goes through this. If they're able to cross this chasm and get into the early majority phase, then they become successful as a company. If you probably did not know this, more than 90% of all software startups actually fail. Nobody talks about failed startups. Nobody wants to talk. It doesn't get media attention, right? You always look at the extreme ones which have been very highly successful. And due to our human biases, we always think that, oh, you know what, if we do a startup, it's just going to work fine. But what I want to tell you is that it's hard work. There's a lot of hard work goes into something which becomes very successful. So even when you're looking at technologies out there, don't just be carried away because it could be a peak of inflated expectations. Look at the history of the technology, look at the history of the framework, look at the history of the library. If it has survived for many years, then there is very high probability that investing your time in it and building something on top of it will yield results. So what we're teaching you here, Pandas, Apache Spark, they have stood the time test. They've been at least for a decade now. They have been applied in various products. They have been very successful and mature and stable tools out there. All right, this is what I always hope for, but the typical response would always be like this. Which is okay, because the first class, nobody is going to conquer the data engineering field. It takes a while to kind of understand this, and it's always good to have doubts. It's always good to question things and have a sense of doubt. Otherwise, you wouldn't be able to discover the number of permutations and combinations you have with the avalanche of information you are bombarded with daily is huge. So you should always look at things with a certain element of doubt. So with that said, I'll leave to the Q&A and open up for any more questions.
Hi there, I have a question. With the open source, is there a way to import what you've done into ServiceNow or Salesforce and Tableau, or do you have to rebuild it on that on their software?
So what we have done, all of our data formats either align with CSV, XLSX, or Parquet. All of these three formats are understood by all the three platforms you mentioned: ServiceNow, Salesforce, Tableau. All of these understand it. So you would be able to import the whole thing into any of these platforms.
Great, thank you so much.
Sure. Let's see, I think let me look at the chat window. Do employers recognize graduate certificates, which most universities? Okay, again, there is a balance in terms of how you should interpret this. No employer is going to give away 100 credits to you as soon as they see a graduate certificate. Oh, data analyst, oh, let me take it. Let me not interview anything. That's not going to happen. Majority of the tech employers would want to have their own test. There is definitely some credit given when they see that you've already spent time on doing a graduate certificate with the universities. No doubt, because that already proves that you are interested and you have shown some amount of dedication towards it. So yeah, there is value, but that does not guarantee a job at. Employers have their own ways of testing. Okay. Any other questions, Yin or Sheikh? Do we wrap it up? How do we move forward here from here?
Well, I'll give it back to Yen. And what question do you have, Yen? Or folks, if you have any other question, feel free to ask. So.
Sorry, I've been muting. I've been talking, but I was muted. Yeah, so my question is, if you can give them one advice for those who aspire to be data analyst and going into this field, to tell them one thing that they should start doing to prepare them on that route, what would that be?
One is a very difficult but since you have
like something they should do like every day or every week, just keep doing
I see what you're saying. So what I would tell is GitHub, constantly monitor for GitHub and search for data analytics projects. And just read what are the top trending ones in their README. There is already quite a bit of knowledge that comes out of it. Pandas, Apache Spark stay in the top all the time.
Thank you.
Yeah, and there are other resources. Again, I'm probably stretching, which will provide you, like there is datasciencecentral.com. These are like websites where, lots of authors. I publish a lot of articles at various other places too, where, there is always, it needs to be, everything is not useful for everyone unless they get to the level of understanding and they've already tried. But then there is all levels: basic, intermediate, professional, expert. All of those articles will be there.
So one more question: what kind of balance should they be looking for between learning and doing?
Yeah, that's a great question, and I can tell you that the way education has moved since early 2000s to now, employers wise, everyone wants more hands-on. It's okay to fail, but do it first. So I initially alluded to this part of extinction by instinct and analysis paralysis. What tends to happen generally in an academic setting, and there is nothing wrong or right about it, right? It all depends on. In academic settings, you generally tend to be towards analysis paralysis. You would like to learn the theory, everything, want to be the perfectionist where you want to learn every little fundamental first before you actually put hands-on into doing something. But I think there is a sweet spot. And if you look at a non-academic setting, especially in some of these fast-moving startups in the Bay Area, they're always about jumping in right then and there and not looking at the fundamentals and applying design patterns that are not mature. And so they end up paying the cost of it 6 months, 1 year down the line. And those are the startups I'm talking about, tend to fail. 90% of them tend to fail. For me, the answer is do both. I know it's not an easy thing, what I say, but that is how things really would work. There needs to be a feedback loop between your hands-on and what you're learning academically.
So I just wanted to add, Pradeep, if I may.
Go ahead.
So I just wanted to add real quick, there are two routes of doing it, right? One really, you are mature enough and sufficient enough to kind of go and figure it out on your own, and you kind of get a suggestion from somebody like Pradeep who has done it for tons of times, right? That's one. Second, you really get into a professional course, right? Wherever you do, you do your due diligence. And doing that, you can kind of shorten your roadmap, that that there are somebody to hold your hand and give you direction, because you're going to flip once you start walking on that road. It's going to be a journey, especially data analytics. Not easy. Like we've already seen tons of tools, frameworks, processes that works together, and then on top of it, the business domain expertise is there. So I've seen the students spends majority of the time troubleshooting and kind of setting up their labs. So these professional courses are good because they give you everything that you need, like labs, set up in the cloud and things like that, right? And a very defined curriculum, processes. But I do understand that it comes with the price, right? So it may not be suitable for all of us, but whoever can afford, I think that's the best route and easiest route to get into the industry within 4 to 5 months.
Great. Thank you, Sheikh. Well, I think it's about time, unless someone still have questions. Maybe you can ask one last question. Otherwise, we're going to wrap it up.
Hi, this is Abdul.
Oh, hi.
Sorry, hi everyone. I don't have a question. I just want to, just thank Pradeep and everybody for attending. And, just to give a brief background, I'm a Queens College alumni, director at Transfotech, but I also work in the hedge fund industry, and I can't stress how important data analytics is. Something that we do at our industry is for our clients that invest in hedge funds, we prepare massive amount of data sets to allow them to see, if oil goes down, by X amount of dollars, how does it affect their portfolio, and so on and so forth. So data analytics is really transforming not only the engineering and the science field, but pretty much industries across the board, whether it be in the financial industry, the advertising industry, the marketing industry. So I just want to stress the importance of data analytics, especially going forward to the future as we see a rise in IoT, smart homes, and a lot of, smart products out there. So.
That's very true. Data is everywhere. Yeah. Maybe before you leave, before everybody leave, maybe Abdul, Pradeep, and Sheikh, if you don't mind, share your LinkedIn. Then anybody wanted to connect with you can connect you there.
Absolutely.
Yeah, just maybe put in the chat, and I'll leave it up a little for another minute or two.
Also, Yen, I would probably send out to you all the materials and the full class curriculum.
Yeah.
If you're interested,
Yes.
They have the first line on the row.
Yes. Yeah. We'll get you all the information if you're interested in further pursue this, especially through the more advanced class here. Yeah, you'll definitely get all the information. I think you're going to also share a link of the recording. Yes, I think last time we did. I think.
Yeah, we can take the recording after. We can edit it, put it on YouTube, and then share the link. I think that might be the easiest.
Right.
Or you recommend something else.
Sure. Yeah. Absolutely.
Thank you. Thanks everyone for participating. Thanks Pradeep. Thanks Sheikh. Thanks Abdul for putting all of this together, and on a Saturday night. Thanks everybody.
Thank you.
And enjoy the rest of the weekend.